I'm Mark. As Carsten already said, I'm part of the Cup Java team here at SAP, and I would like to talk to you today about native images. We've recently released our Cup Java 2.0 version, our first major release in Cup Java, and it is based on JDK 17 and Spring Boot 3. And one of the key features that was added to Spring Boot 3 was Spring Boot's native image support. And we have invested in the last few weeks heavily to also bring this native image support also to Cup Java. And I would like to share the results of this in this talk, and therefore touch on 4 different topics. So we will first talk about what are native images, then what do you need to do for your application to build your app as a native image. Then we will talk about what we did in Cup Java to better support native images. And then finally, I want to give a demo about a native image use case, a scale to 0 scenario. So let's first start with what is a native image. Native images basically enable you to package your application as a standalone precompiled executable. It is no longer running on the Java virtual machine, but it actually is a fully standalone executable that has all everything in place. So everything that is usually provided by the Java VM is also part of that executable, like garbage collection and thread management and all that stuff. And as it's an executable, it is no longer as portable as you're used to with jars. So it's really fixed to a specific operating system and architecture. But in the cloud world, this is not really a big problem with things like Docker and stuff like that. So, but let's take a look at an actual application and what native images mean for an application. So I'm showing you everything today with the Cup S-Flight demo application, and you can try out everything also on your own. So all of the code that you require to do this is already part of the main branch and released. So let's first run the S-Flight application as a traditional jar. I directly run it here on the Java VM as a jar, the Spring Boot executable jar. And it takes some time to start up. As you can see, it takes roughly six seconds to start up. And here on the right-hand side, you can see it consumes around 300 megabytes or 400 megabytes of memory after startup. So now let's run the same application as a native image. So I will start the same application, but built as a native image. As you can see, it starts up much, much faster. It only takes 0.4 seconds. And it also has a very lower memory footprint directly after startup. So it only takes up around 150 megabytes of memory. And this is what makes native images so interesting for cloud deployments, because they have much faster startup times and use less memory. And less memory in the cloud basically also means reduced costs, because you have to pay for every megabyte of memory that you use. And the reduced startup time enables new deployment possibilities, as we also see in the final demo. All of this technology is enabled by GraalVM, which is a special Java virtual machine distribution that was originally built by Oracle. Oracle, meanwhile, open sourced this, and this is part of the OpenJDK. So it's maintained by the OpenJDK, and you can use it for free. It's distributed under the name GraalVM Community Edition. There's also an enterprise edition from Oracle, actually, which has additional features that are not open source. And just a few days ago, very new news, this enterprise edition from Oracle was also now released for free. So you can also use it for free as well, next to the community edition. Yeah, so now that you know about this technology and are hopefully as excited as I am about this, let's talk a little bit about how do you actually build an application as a native executable. What do you need to do? So the good news is you almost need to do nothing. So you don't have to change any line of code, or most likely you don't have to change any line of code. But there are some boundary conditions that you should be aware of for these native images. So first of all, it's important to know that this ahead of time compilation phase actually analyzes your application from the main entry point, which for Spring Boot applications, this is usually the application class. And it checks which classes are statically reachable. And all of the classes that are reachable will be included into the native image, and everything that is not reachable will also not be part of the native image. This basically means you cannot add certain dependencies or classes that you only at deploy time or at runtime, what you could do with a JVM standard jar deployment. But you really need to know the whole class path already at build time. Second is that the native image needs to be informed about all of the dynamic elements of your code. This basically means these dynamic elements are reflection usage that you have, or resources that are usually packaged in the jar, or also dynamic JDK proxies. And for most third-party libraries, such as Spring Boot and many other popular third-party libraries, this reflection information is already part of the libraries and frameworks themselves. So they bring that pre-configured for you. And also, this is the case for CapJava. So we have added these configuration files to CapJava as well. But if you use some of these things in your own application, you need to provide special configuration files for this. So let's take a look at such an example. Here in the S-Flight application, we actually had to provide one such configuration file, which is usually placed for application under server source, main resources. There's a meta-inf folder, and in that meta-inf folder, there's a native image folder, and in that you can place all these configuration files. And we had to here add one resource config JSON file, because we are using one resource that is usually packaged into the jar that we now need to have to include in the native image. In our case, this here is the messages properties file, which is a Java resource bundle that contains some error texts that we want to be able to translate, and therefore we maintain it in a resource bundle. And with that configuration, the native image build knows that this file should be included into the native image. For Spring Boot specifically, there's an additional thing you need to note. Actually, for Spring Boot application, it's important to understand that all of the bean definitions in Spring Boot, they need to be known already at build time as well. This is a slight paradigm shift in Spring Boot. What this basically means is that all the beans that are profile or property dependent, you already need to decide at build time whether you want to include them into the native image or not. Here we have one example in the S-Flight application. We have this redirect filter bean here. It's not so important what it is for, but the important thing is that it's profile dependent. So it only is activated when not running in the cloud profile. So basically, we now have to decide if this bean should be included into the native image or not. And we do that by already providing this profile information to the native image build. You can do this in POM.XML, for example. Here you can configure this ahead of time phase from Spring Boot and specify that you actually want to run it with the cloud profile, which basically instructs the build to not include this bean in our case. Also, CapJava creates various beans in the Spring Boot bean factory based on external configuration, such as most likely service bindings. So usually you have, for example, a HANA service binding when you run the Cap application, and that instructs Cap to actually create a data source bean for you in your app. And also this decision now has to be taken already at build time, which is why we, next to the profile, we also provide this native build-env JSON file to the CapJava framework, which basically tells CapJava, okay, during this ahead of time compilation phase, please make sure that you prepare the native image so that we can later run with HANA, and here also with an XSUA binding when running in the cloud. You don't need to provide any credentials here, just the service binding metadata, so things that you usually also specify, for example, in your manifest YAMLs for Cloud Foundry or MTA YAMLs for Cloud Foundry deployment. So this kind of information also needs to be instructed to the build. And you kind of realize with that actually this native image build is something that you do right before deploying into the cloud. So it's really the last step, and you actually also know already about your cloud deployment target, and some of this information goes into the build of the native executable. And for local testing and locally running the application and all that stuff, or unit testing also, most likely you still do most of that stuff still with the jar and on the JVM. So this native image is really for the deployment in the end. So now you might ask yourself, okay, now I've configured my application. Actually, that was everything we needed to do in S-Flight to make it ready for native images. How do I actually now build my application as a native image? And also this is super simple. If you're using the Spring Boot parent POM, you can just directly execute Spring Boot, build image, and pass the native profile. And what this does in the background, it builds the native image as a Docker container using cloud native build packs. And basically, the only tool you need to have installed locally is Docker, and everything just runs. And you get in the end a Docker container that is optimized for cloud deployment with a minified OS optimized for security, which is really cool. Alternatively, you can also use the Maven native compile goal, which basically builds the native image directly for your machine architecture that you're running the command on. But this means you also need to install additional tools like GraalVM and some build tools like GCC or so that is required to run this build, which is not the case with the Docker approach. And while the build is running in the background, as you can see, it takes some time. It takes for S-Flight roughly 4 minutes. I actually want to talk to you a little bit about what we did in CapJava to better support native images. And our main goal was really to free applications from having to provide these configuration files as much as possible that you saw earlier. And I think we are in a very good position here. We have really minified that. And the interesting thing is that, so for all of the reflection that we just know about in CapJava, it was pretty easy to also provide these configuration files as part of our framework. But CapJava also uses reflection on a lot of classes that are actually not known to us, but that are actually part of your applications. So most prominently, these are the event handlers in CapJava, which you provide as normal Java classes. And you have these before or on annotations that you use to register event handler methods. And we detect these methods through reflection by inspecting the annotations, by inspecting the method signatures, and then we also invoke these methods through reflection. And another area where we are using dynamic elements heavily is with the generated interfaces that are generated based on the CDS models. So for example, here in the S-Flight application, we have this booking interface that was generated by our CDS Maven plugin. That can be used to access booking data in a type-safe way. And we also generate these classes with the underscore in the end, also for each entity, which can be used to have a typed query builder API when building select statements, for example, for bookings here. And what we do at runtime, we create JDK proxies based on these interfaces. So we somehow need to instruct the GraalVM build that we have this requirement that we need reflection on these event handler classes and JDK proxies for these kinds of classes. And we really wanted to ensure that you don't have to provide this in the application. So luckily, there's a mechanism in GraalVM which allows us to add an additional plugin and a feature to the GraalVM build. And I also down here, I paused hopefully at the right point in time. You see, here during the initialization phase, it picks up our CDS AOT feature, which is an additional plugin to the GraalVM native image build that is coming from us. And what we do in there, which is really nice, you can register reachability handlers. The GraalVM build basically informs you, for example, whenever it finds a class is reachable that implements the CDS data interface. And we know for these classes, we need proxy usage. So we can register that for you automatically. The same for the structure type interfaces, which are for the Query Builder API, and also for all event handlers, because they all implement the event handler interface. We can also register the reflection pattern that we need, that we know that we need on these classes. And this makes it really easy to build your CUP application as a native image, because you don't have to deal with all these special configuration files that are would just be required because of CUP Java, but we actually free you from that. As we can see, the build here finished now. We now have the Docker image. Took about 4 minutes. And now that you know about also some background information, how this native image support actually works in CUP Java, I would like to come to the final demo and actually see this Docker image that we just built in action. So one use case that came to my mind when I saw the first fast startup times of these native images for the first time was a scale to 0 scenario. So enabling your application to really shut down completely and scale to 0 and only start up when a request comes in. With 5-6 seconds startup time, this feels a little bit unacceptable, but with a few milliseconds, this feels far more reachable. So what I did is I deployed the CUP S-Flight application into the SAP BTP Kyma environment, which is a Kubernetes environment. And we have there a HANA service binding and an XSUA service binding. And I also deployed the HTML5 Fiori applications to the HTML5 apps repo, leveraging the managed app router. And with that, I can show you here. So let's clear that. Let's take a look using kube control. Take a look at the pods. As you can see, currently there are no pods running in my Kubernetes namespace. So there are still some deployer jobs that have finished, however, but the server backend is not running at the moment. And now let's switch to the UI, which just locked me out. Let's sign in again. So here we see the Fiori Launchpad with the S-Flight UI applications here. And if I click now on the process travels, you will see down here that the pod for the server backend actually starts up when I click on this tile. Oops, sorry. It still takes some time to run, but the application is up really fast, and then you see the UI loaded, which is really, really cool. So basically, this can enable you to save even more costs for applications that are very infrequently used or mainly used during specific timeframes. As you can see, it still takes some time. It's not instant, so this whole approach can still be optimized, but the important thing is the Java backend is no longer the bottleneck in this. So it still takes some time, for example, for the Kubernetes environment to detect the pod as running and all that stuff. And this adds up a little bit. In worst case, you maybe even run on a new Kubernetes node and you need to pull the Docker image. So all of this can happen. But I thought it was a nice experiment that is now much more approachable from my perspective with native images than it was before. Yeah, so we in CUP Java are definitely very excited about this technology, and I hope I could ignite some of that excitement in you today as well. This is still all very new and early, so feel free to try it out. You can try it out already today for your applications with our latest CUP Java 2.0.2 release, or try it out in S-Flight. All of the changes are in the main branch. And yeah, let us know if it works for you, or let us know if you have issues. We're always interested to get to know if this is something that you're interested in. So thank you very much for your attention.